In the last semester, we have discussed a lot of, not lot of, quite a few power station. So at first, sir, what is power station? Power station is, to be very frank, where basically the power generates. Okay, so basically it's a power plant. We're discussing about power plant, so we'll discuss about different types of power plant. We already know the steam power plant. I have discussed a little bit of gas turbine power plant. So in this course, we also discuss the steam power plant. Remember, steam power plant is also known as thermal power plant. So we'll discuss steam power plant. We will discuss gas turbine power plant. We'll discuss nuclear power plant a little bit, diesel power plant. So hydroelectric power plant, we discussed a little bit in the last semester, but we'll discuss it thoroughly. Hydroelectric power plant. So, and also see the basic and practical some structure, also some practical structure and the practical calculations done in the power station. So as we have already know the different types of power plant, so I'm just not starting the courses with the different types of power plant, because already we know some of it. Because if I start that topic, you will feel something like bored, because you will think that it's a new semester, new course, it should be a different topic. Yeah, it is quite a different, not exact similar, but quite a bit similar, because the topics are almost similar in some parts. So I'm starting with a new topic, totally new topic. This is known as variable load on power station. And before starting, the not syllabus, the basically the reference book they're talking about. The reference book, I think you all have the BK Mehta book, The Principle of Power System. That will be the reference book from 1 to 6 chapter. That is quite related to the power station. So BK Mehta, Principle of Power System. I think everyone have that book. If you don't have, please knock me in the messenger. I will email the soft copy of that book. Okay. So the first today's topic is basically the variable load on power station. The variable load. So what does variable load means? Fixed is the opposite word of variable. Okay, I'm just one more ensuring that my sound is okay. So that's why I'm one more time I'm unmuting my all students and just checking for all. Sound is okay, my student? My sound is
Yes,
okay?
sir. It's good. It's
Yes,
good.
sir.
Good.
Okay, so everything is good. Okay.
Yeah.
Okay. Nice. Okay. Okay. Thanks for the feedback. So, okay. So what does variable load means? So basically variable load is on power station means, we all know that power station is a power plant where basically the power is generated. So you know that everyone, all the customers, consumers are connected with the grid. And we all know that in the power system there are three sections. One is generation, the middle one is the transmission and distribution, probably you have studied a course right, like that, and last one is the distribution, basically the consumer. Okay, so in this three section there should be a coordination. That suppose there are five family, every family requires 100 megawatt. Not 100 megawatt is a very big power. Suppose 1000 kilowatt. So total capacity is for five people, for five families, 5000 kilowatt. So your demand or requirement is 5000 kilowatt. So your generation capacity also should be 5000 kilowatt. Why? Because if we generate more, the AC power cannot be stored. Okay, we all know that the DC power can be stored using battery, but the AC power cannot be stored. So that's why there should be a coordination. So variable load on power station means we all know that everyone in the country is connected with all the power stations. So basically the load demand is varied because everyone is not using the power at the same time. Some people sleep in the morning, some people sleep in the late night, some people sleep in the early night, and some people watches TV sometimes. Some the means I'm talking about that everyone's demand is not the same. So in sometimes the demand can be less, and sometimes the overall demand can be high. So that is variable load. Okay, load is basically means that our demand for consumer demand basically is the load. So the variable load is basically the change of the demand within the time. Because every time the load is not same, because we are not using the all appliances at the same time for. So that is the thing, you see that uh, all I discussed, the load on a power station varies from time to time due to uncertain demands on the consumer. Because you know that some consumers uses power in some time, some consumers uses power at other time. So that's why it varies time to time. It is not fixed, it is variable. The demand is always variable, and that is basically known as the variable load on the power station, or specifically on a power plant. Okay, I think you understand the what is the variable load constant or concept. So if the fixed load was there, then it was quite easy to maintain. But when the load becomes variable, because anytime the load can be higher, the load can be bigger. So that's why you see in our country the load shedding. The load shedding happens because it at the peak time it becomes very high, but in the morning you see that the very less amount of demand is there. So it varies. So that's why there are some impacts, there are some effects of this variable load on the power station, and for that some thing happens in the power station which should be mentioned. The first thing is basically we're talking about effect of variable load, that how it affects in the power station. The first thing is it requires additional equipment. Okay, additional equipment. The effect of, as the load is variable, that's why it requires additional equipment. Now the problem is, sir, how or why, how this additional equipment gives us those things. So you see that in the, suppose we discuss about steam power plant, suppose. So in the steam power plant, you know that steam power plant is basically generated or performed using steam. Okay, so when the high demand is happening, so that means that high amount of power we require. So definitely we need to provide large amount of steam to the steam turbine. At that time it will give much more power. Okay, but Abdiaziz says sound problem. Let me check. My students, sound problem? Is there any sound problem? Is there any sound problem?
Okay, sir.
My side.
Yes, sir.
Right.
Sometimes it's a problem. Sometimes
Now,
it's
now,
drop
now,
part.
now.
Oh, it's okay. Yeah, yeah,
Now it is okay.
yeah. Okay.
Yes, sir.
Yes, sir.
Okay.
Okay.
Okay. Please give feedback in the chat box. I'm there. I'm frequently checking your feedback in the chat box, so you can definitely give your feedback, your question, and if you are new here, just give your role in the chat box. So, what was I discussing? The discussing that suppose when we require so much power, so in the steam power plant we require much more steam. So in sometimes you see that the demand becomes very less. So at that time we need less steam to be provided in the steam turbine. So you see that there is a variation. The variation, you know, because sometimes it requires more power, sometimes it requires less power. That is the thing of variable load. So to maintain that, to maintain or to establish that facility, we need some extra equipment. One equipment is known as governor. The governor basically maintains the amount of steam will be provided to steam turbine. So these are the extra equipments needed. Okay, that's why it's a kind of lackings. See that in order to, so that it's mentioned that in order to produce variable power, the supply of these materials will be required to vary correspondingly. Yes, because when the demand is high, we need more steam. When the demand is low, we need less steam. So to maintain these characteristics, or to maintain this status, we need additional equipment to be installed for perfectly doing this job. So this is one of the effect of the variable load. Next, if we discuss, it increases the production cost. Okay, it increases the production cost. Sir, how? Suppose think about a region. Suppose Dhaka needs 50 megawatt power. Suppose 50 megawatt power. So for its, suppose at 6 p.m., we all know that the evening is the peak time. Everyone tries to use their appliances in the evening or night. So at that time it requires 50 megawatt. But we all know that in the morning time or in the daytime we require less. So that's why how it increases the production cost. So for providing that power of 50 megawatt, if we use a particular alternator or generator of 50 megawatt, so we should know that every equipment has the best efficiency when it is working at rated ratings, when it is operating as in its rated capacity. Suppose that we are using one generator capacity of 50 megawatt to provide that power, but that generator is providing power properly in the evening time. That is not a big problem. But when it comes to the morning time, we are not requiring 50 megawatt anymore. We are probably requiring 20, 25, 30, something like that. But at that time, if we generate the power using the same generator, it will not working at its full capacity or full efficiently. Okay, so at that time there will be losses. So to remove this, suppose now we have 5 generators. Every generator has capacity of 10 megawatt. So 5 generators. So in the evening time, total 5 generators are operating, and in the daytime, suppose 20 megawatt is required. So 3 generator is shut down, 2 is operating. Suppose 30 megawatt is needed, 3 is operating, because now every small generator is operating its full capacity or its full rated capacity. That's why the efficiency is much more. But what creates the problem? Creates the problem that you need to establish so many generators. Okay, so which eventually also it requires much more floor area, much more area required to establish that whole setup. So basically overall process gives or makes the production cost very high. So that's why the effect of variable load, if the load was 50 megawatt all the day, all the night, it will, no problem, because it is already operating its rated capacity all the day, all the night. But in the morning, less power, in the evening, high power. So that gives a variable load. So this is one of the very big effect, which is eventually increases the production cost. So going to the next slide. A very important topic, which is known as load curve. Okay, load curve is very practically driven topic, load curve. So what is load curve? The load curve is a record of loads during the whole day. The load curve is the record of loads during the whole day. It can be whole day, it can be whole month, it can be whole year. Okay, so you see that load curve is basically showing the variation of load on the power station with respect to time. And from this graph you can see that there is a variation, so what does it mean, or how to generate a load curve? Basically I'm saying you exact practical information because I have visited quite a bit power stations. So how they generate this kind of load curve? Basically, the every half an hour one person every half an hour one person is dedicated to record the power that is supplied. Okay, every half an hour that is supplied, that data is recording. So if we record that data every half an hour, so that means we have a total 24 hours, that means 48 data. So for 48 data, if we plot 48 data, and the power, the data, so definitely that will be power. Some will be 2 megawatt, 4 megawatt, 6 megawatt, 8 megawatt, something like that. If we plot those value or the load in the megawatt in the y-axis, you see that in the y-axis, and the time, and in the time in the x-axis, if you plot those value, we and finally joining joining all the point, we get the load curve. And basically the load curve shown in this diagram is the daily load curve. You see that, the daily load curve. So what does it means? It means that it has the records of the whole day. From the daily load curve or the load curve, we can say that when the maximum load is given or when the lowest load is given, and how the load structure, how the demand structure was throughout the day. You can see that the maximum peak, can you see it? The maximum peak gives us the maximum demand. That means at 6, this is at the evening, at 6 it has the maximum demand. Okay, and you can also see that in the late night after 12, 12 to 1, it requires a very less amount of power. So it gives us the overall scenario of load needed for a particular customer area. So the load curve is very important because it gives us that scenario to see that when the maximum load is given or the maximum demand is given, or when is the less amount of given. So interesting thing is that one thing I will discuss very advanced, will be discussed later also, but very advanced. You see that the load curve is very important for selecting the capacity of a power station. Selecting the capacity of a power station. Capacity, how? So suppose you see that this is the load demand of a zone, of a area. Suppose Dhaka, you see that maximum it has at 6 it has maximum 6 megawatt. You see that maximum 6 megawatt it has required, or the demand is a maximum 6 megawatt. So what if we want to build a power station, that means a power plant, to supply these customers? What should be the capacity? The capacity should be selected, the capacity should be selected by analyzing the load curve. How? We should at first see what is the maximum demand of their zone. From this graph we can see that the maximum demand is 6 megawatt. Okay, so the minimum capacity of that power station should be at least 6 megawatt, because if it is less than 6 at 6 p.m. or at the evening, it cannot supply the power to all consumers. So there should be some load shedding, there should be some people who will not get the power at that time. So the minimum capacity should be 6. You see that minimum capacity should be 6, so at that time it can give the power, and in the rest of the time, in the day or night, definitely it can supply the power, because the rest of the time it is definitely less than, the demand is less than 6, the demand is less than 6, so it can also provide the power at the other time. So always remember that to select the maximum, to select a capacity of a power station, we should select the maximum demand from the load curve, because the maximum demand gives us the minimum capacity required for the power station. Okay, if I discuss one more thing in advance, that is, sir, should we select the power station capacity 6 megawatt? If I was the selector, to be very wisely, we shouldn't select 6 megawatt, because we all know that in the capacity wise, if we select 6 megawatt, in future there should be some expansion. Okay, in future there should be some expansion, so at that time, who is drawing something, so at that time, it cannot supply within this with the 6 megawatt. So always take a greater value than 6 megawatt, so that is called as reserve capacity. Okay, we need to suppose it is 6 megawatt, we should select the power station capacity 8 megawatt. So basically we are taking 8 minus 6, 2 megawatt as a reserve capacity. Okay, as a reserve capacity 2 megawatt, so at that time it can give 6 megawatt definitely, but in future expansion we have already 2 megawatt reserve. So in future expansion, if more consumers are added, they can also be supplied from this power station. I think you are clear. I'm discussing this topic a very little bit earlier. So importance of the load curve we have already discussed, but before discussing, sir, this is the daily load curve. Sir, how can we generate monthly load curve, or how can we generate yearly load curve? Okay, that should be the question, sir. How can, this is the daily load curve, sir. This can be done, you taking half an hour every data, you can plot daily load curve. So what is monthly load curve? So basically monthly load curve is, just generated at that time you require 30 days load curve, 30 days. So suppose 12 at night, we have 30 data of every day. So we sum all the 30 data and divided by 30, that means getting the average data. So for making the monthly load curve, we have to take all the 30 data of each point, summing all, divided by 30, getting the average data. So we get all the average of the, you know 48 points every on half an hour, every points is the average point we get. So after that, plot those average point in the graph, we get finally the monthly load curve. Similarly yearly is same, yearly load curve is same. You take, all the data and give the average, and finally getting the yearly load curve. These are not done by, uh, human being by manual calculations. These are done in the software. In the software you just you give the data, and this automatically gives the calculations, and finally gives the, you know finally gives the output. The importance already we discussed, that it gives us, it shows us the different variations, that when is the maximum, when is the minimum. The second line, you can see that the area under the load curve gives the number of units generated in the day. Okay, so what does it mean? It means that the area under this load curve, the area, this area gives us the idea that how much energy we generated throughout the day. Okay, what does it mean? It means that suppose our demand is 2 megawatt at 12, so that means we are producing 2 megawatt. Our demand is, at morning, suppose 7, 4, so we are producing 4. So and every time our demand will be matched our production. So if these are the all thing are demand, so definitely we are meeting this demand by our production. So if we sum the whole area, we'll see the mathematical problems, we'll see how we'll sum this kind of area. So if we sum all the area, basically that will be the the summation of our units generations throughout the day. The third point is the highest point of the daily load curve represents the maximum demand. I already said that the highest point is the maximum demand of the station on that day. The last, the area under the load curve, basically the area I discussed, divided by the total number of hour gives us the average load. Yes, gives us the average load. If I can sum area, all the area and divided by 24 per 1 hour, it gives us the average load. So basically the whole area we sum and finally divided by 24. So every hour, 1 hour, we can decide that how much load is given or produced or unit generates average in average term. So that was the importance of the load curve. Please, I think you understand that thing. And it also has important, if we find out the average load, we can also find out one more factor we'll discuss later. So these slides you will understand when we discuss the load factor. So I'm just unmuting all till now. If you have any suggestions or any something like that, I'm unmuting all. My students, everyone is unmuted. I think you are listening and everything is good right now till now.
Yes, sir.
Yeah.
Okay.
Yes, sir.
Okay. Nice. Thanks for your feedback.
Yes, sir.
Try to give your feedback in the chat box, so that's why I can understand. Okay, everything is going well. Okay, still you have any doubts in your minds, you can definitely give your comment or your suggestion in the chat box. I'm constantly checking. So should I continue?
Okay.
Yes, sir.
Yes, sir.
Okay. Okay. Thank you. So thank you for your feedback. Okay, now we will discuss some of the important terms and factors. Whatever we are discussing today is a very important topic and also very practical topic. This is not that just we are listening. No, it is applied practically in the power station everywhere. So very important topic. So the first thing is the connected load. Okay, the connected load. The connected load is basically, I will say, you just roam around your eyes in your room, current room. In your current room, you just see every electric load. You see fan, you see light, you see power point, you see the different dim lights. It can be iron machine. So everything, not iron machine, you see power point, you see, but every load connected in your room, not mandatory should be on, not mandatory should be, I should, suppose I have three lights, should I consider both three lights? Yes, because every lights are connected within the electricity current or electricity connection. So basically connected load is the sum of all loads that is connected with the supply system. Every light, fan, your all the power point, 2-pin plug, 3-pin port or 6-pin port, everything that is connected, that is not mandatory that it should be in the power line already, that we are operating both three lines. No, not like that. Whatever the connected, that is the basically known as the connected load. Suppose for instance, in the screen you can also see, if a customer has connection of 500 watt lamps and a power point of 500 watt, so basically at that customer the connection load or the connected load will be 5 into 100 plus 500 equals to 1000 watt. Okay, so similarly you see that the sum of suppose in our home we have 1000 kilowatt, Suppose other homes has 2000 kilowatt. So if we sum all those connected load under a zone, we will get the connected load of the power station. That's why it is told the sum of the connected loads of all the consumers or the customers is the connected load of the power station. I think you understand. It's just the connected, not in the power already in the live, not like that. It's just a connected load. Maximum demand. Maximum demand. We already discussed what is maximum demand. From the load curve, we see that the highest peak of the power station daily load curve. Okay, but still we have our individual maximum demand. Understand, it is the greatest demand of load on the power station during a given period. For a single day, we already see this is the maximum demand, the highest peak of the power station of a given day. So this is basically the maximum demand. This is the power station maximum demand. But one more important thing I will discuss in advance, that is one more thing I will discuss, that is the individual maximum demand. Okay, the individual maximum demand is something like that. Suppose I have my home and I use maximum demand. Suppose at the noon, when we are all the family members are home, we take our lunch, we see the break, the TV, everyone is charging their mobile phone. So it happens in my family, but what about others? Some people, they like to use all the things in the night. Some thing, some suppose in the school, the maximum demand happens at the morning, in the morning. And also suppose in the shopping mall, it happens in the evening. Okay, so the individual maximum demand are not the same at the time, so it also varies. So remember one thing. Okay, so individual maximum demand is not happening at the same time, because I have the maximum demand in my own time. Probably Abdi Aziz has his own time, probably shopping mall has its own time, school has its own time, mosque has its own time, 5 times a day. At that time, all the loads are on. So what I'm trying to say, that the maximum demand of individual, it cannot happen, or it may not happen at the same time. Okay, so that is the difference of individual and the power station maximum demand. But here we are discussing the power station maximum demand. That's why I'm telling about that is the greatest demand of load on the power station during a given period. Okay, so why I discussed the individual maximum demand, because there is a factor, or there is a special term known as diversity factor, we'll discuss later. That's why I'm just giving an explanation that what is the individual maximum demand and what is the maximum demand of the power station. Both things are not same, okay, so that's why I discussed. Okay, the next thing is that the demand factor. So what is demand factor? So demand factor is a ratio. That ratio is the maximum demand divided by connected load. Okay, that is the ratio. So maximum demand divided by connected load. So what does it means? It means that maximum demand, suppose in my home, maximum demand, suppose I have 5 lights, 2 fan, but at the same time I will not use all the things at the same time. Okay, all the things not at the same time. So at that time, it can be you know we have connected all the loads, 5 lights, 2 fan, it's connected, but I am not using everything at the same time. So always think that the value of the demand factor is always less than 1, because the maximum demand is not the same as the connected load. Probably I have taken the connected load more, but I'm using less. Sorry. So you see that the maximum demand value will be less, the connected load value will be bigger. So when we do the ratio, definitely the ratio will be less than 1. And it is expected because the maximum demand on the power station is generally less than the connected load. Similarly, on the power station, everyone is connected. So everyone has, created so many power line, but they are not using all. They are not using at all. I have in my home, I have 3 power plug, 2-pin plug, 3-pin plug, 1 6-pin plug, but I am not using at all. Right now I am using 1 power port, but 2 power port are empty. So but these power ports are connected. This power port is connected, but I am not using at all. Right now in my room, I'm using 1 light, 1 fan, 1 power port. But interestingly, I have 2 fan in my room, 3 lights, and 3 power port. So this is the maximum demand I am using right now. And always we use only 1 fan, 1 light, and 1 power port maximum. But we have connections, more than 3. You can also see your room that you have 1 or 2 extra light port. Okay, so something like that. So that's why what I'm talking about, that connected load is always bigger than the maximum demand. So that's why the demand factor is always less than 1, because the maximum demand is less, the connected load is bigger than the maximum demand. Suppose an example is given. If the maximum demand of the power station is 80 megawatt and the connected load is 100 megawatt, then the demand factor will be 0.8. So what does it means that 0.8? The 0.8 means the maximum demand of that power station is 80 megawatt, but the connected load was 100 megawatt. I think you understand the demand factor. Okay, average load or average demand, whatever we say, same thing. Average load or average demand, same thing. We all know what is average. So daily average load, I directly go to the equation. Daily average load, monthly average load, yearly average load. Suppose a power station in a day produces 500, not 500, suppose 5000 kilowatt. 5000 kilowatt in the whole day. Probably in the whole day, suppose 24 hours, 1 hour they are producing less, 1 hour they are producing bigger than that, 1 hour is less, 1 hour is high. It's not like that. We just summation of all, summation of all units of the whole day, and then divide the number of hours, of that particular time. So for daily average load, we need to number of units generates in a day divided by 24 hours. Similarly, monthly average load, number of units, that means power unit, kilowatt hour. We all know that kilowatt hour is a power.
Hey, hey.
Sound connection. No sound. Waxaan ku dhaha macalinkaaga.
macalinka quraaca doontanimaya
حتى macalinka lift ma qaata.
shubka macalin marka baxmaa video soo galaysaa
Students, can you listen?
Yes.
Students,
Yes, sir.
Yes, sir.
Okay, the problem was I was using Wi-Fi. Suddenly, the power of my connection gone, and came after 2 seconds. So that's why the problem happens. I think you will see this in a
No problem,
sporting
sir.
manner. Okay, so we are discussing about power. My power has gone. Mm, okay. So okay, I'm sharing the screen one more time. Okay, we're discussing the average load. We're discussing the average load. So basically, the thing is, sir, whatever the units we generated throughout the time, probably I need to mute all. Okay, now it's done. Sorry for the interruption due to the power crisis, but unfortunately we are studying power stations. Okay, the average load occurring on the power station, in a particular time, and divided the whole amount of units generated by the hour. So basically, the number of units generates in a day divided by 24 hours, the number of units generated in a month divided by number of hours in a month, just like 30 into 24, you will get the number of hours in month. Similarly, yearly average load, total generated in a year divided by the amount of hour we get in the whole year. 12 months into every month has 30 days, 12 into 30 into 24, we'll get the 8,760 hours. Okay, so that was the average load. Okay, so the next thing is the load factor. A very interesting thing, the load factor. The load factor is basically it's a ratio. The load factor is basically the ratio of average load and maximum demand, basically average demand by maximum demand. Okay, so you see that the load factor equals to average load by maximum demand, or average demand by maximum load. So if we just multiply with that amount of time t, the equation will be something like that. But the interesting thing is that the load factor is always less than 1. Why the load factor is always less than 1? Because the average load is smaller than the maximum demand. The average load is the smaller than the maximum demand. Why this happens, I will go to the diagram, the load diagram, so that you can understand the thing. The average load is always less than the maximum demand. So how we get the average load? That is the thing. So basically we get the average load by just adding every value. Suppose at 12 the value is 2, sorry, its value is 1 megawatt. At 2 the value is 1 megawatt. At 4 the value is 2 megawatt. At 6 the value is 4 megawatt. At 8 the value is 4 megawatt. So everything has the value. So we add all the sum, we add all and sum and divided by 24, we get the average load. But what is maximum demand? So maximum demand is 6. Here we can see that the maximum demand is 6. So how we get average load? We get all the value at the particular point, sum and divided by 24. You see that only one value is 6. Only one value is 6. So when we make the average load, the average load will be definitely less than 6, because it has only one value of 6 and all the value are less than 6. So when we sum and divided by 24, definitely it will be less than 6. But the maximum demand is 6. So as the average load is less than 6 and the maximum demand is 6, so the ratio will be definitely average demand by maximum demand. So the load factor, which is a load factor, the load factor will be always, less than 1. So we're going our exact slide. See, the load factor is always less than 1 because of the average load is smaller than the maximum load. That's we discussed that why the average load, because all the average load we get take all the value of every point, but every point value is less. Only one value is big, that is maximum demand. But when we make the average, it becomes very less. Okay, so that's why this is less than 1. The load factor is less than 1. Okay, the next thing is that the diversity factor. The diversity factor, what does diversity means? If you know that diversity means different, diversity means different. What is diversity culture? Diversity or diverse culture, diverse culture is a difference, not same. So the diversity factor will basically a relation between maximum demand of the power station and the maximum demand of individual people or individual consumer. I discussed already that what is, how it can change or it can affect, but still I'm discussing one more time. Basically, maximum demand of the power station can be found in the load curve at 6 p.m. at the evening. It gives the maximum demand, or it has the maximum demand, but individual people may not have the maximum demand at the same time, because everyone is different, everyone's usability or need is different. Suppose I have a school, suppose Monima has a school. His school operates at morning time. So all the students are present in the morning time, so all the rooms should be, electricity use should be at that time, morning time. So the maximum demand of that school happens in the morning. Similarly, suppose Liton has a coaching center, and he runs the coaching center in the afternoon. In the afternoon, so student comes, he teaches the students, and all the electricity equipments are on at that time. But the rest of the day and the rest of the nights, the capacity is not high. Only that time it has the maximum capacity or the maximum demand happens. So for Monima it happens in the morning, for Liton it happens in the afternoon. Similarly for me, it happens in the noon. All the members are present in the noon. After salat we take our lunch, then we watch TV together, so it happens in noon. Similarly, one students or one family can happen in the evening, one can have at the night, late night. So it's totally different. What I'm talking about is totally different, and it varies to person. So that's the diversity of power uses. Okay, but for the power station, because everyone is connected with the power station, so for that time we need to see the load curve, because load curve gives the whole load demand for all consumers. So at the load curve, the peak point is the maximum demand for the power station. So what is the diversity factor? Now coming to the diversity factor, the ratio of the sum of individual maximum demands to the maximum demand on the power station. You see that the upper side is the sum of individual maximum demands and maximum demands on the power station. Sum of individuals, suppose I just discussed Monima, me, Liton, suppose Shaun, everyone has its own maximum demand. If I sum all, we get a value. And if we are all are connected in a one power station, and power station has a load curve, it has the maximum demand, that value will be the lower value. So definitely the sum of the individual maximum demands will be much more bigger, because it happens not at the same time, individual time, everything is maximum, but at the maximum time, for suppose for 6 p.m. or the evening, for the power station, suppose my family is not using the power, suppose Monima's school is not using the power, okay, suppose Liton's coaching center is not using the power at that time, so it is not the biggest. It is not the biggest for all. It is the maximum demand at that time, but when we sum all the individuals maximum demand, it will be much more bigger. So that's why the upper value is bigger, the lower value is smaller. So always the diversity factor is greater than 1. That's the thing I was discussing. You see that a power station supplies load to various type of consumers whose maximum demand generally do not occur at the same time. So therefore the maximum demand of the power station is always less than the sum of individual maximum demand of the consumers. I think you understand. Okay, plant capacity factor. The plant capacity factor is one more factor, that how much from your capacity the plant has been used. It is the ratio of actual energy produced to the maximum possible energy that could have been produced during a given period. Suppose Omar is present with us, we know. Suppose Omar has the uh, capacity of, he can pull 20 kg. He can pull 20 kg of weight, but right now he is pulling 15 kg. So he could have pulled 20 kg, but right now he's pulling 15 kg. So how much capacity he's using? So what he has right now pulled, and how much he can, how much he can pull. So actually he's pulling 15, but he can pull 20. So basically 15 will be the upper value, actual energy produced, but maximum he can pull 20. So that's why it is the plant capacity factor is the actual energy produced divided by the maximum energy that could have been produced. Okay, so actual energy, basically actual energy produced, that is the average load we produce. So if we just write the average demand or average load, same thing, and T, and the maximum energy, definitely the plant capacity, the capacity, that is the maximum capacity, that is the you can produce. Suppose the average demand, if we sum all the value of throughout the whole day, the average demand will be 30 megawatt, but the plant capacity is suppose 50 megawatt. Okay, so something like that, the plant capacity is always bigger, the average demand is less. So the plant capacity factor equals to the average demand divided by the plant capacity. The next thing is that reserve capacity. I already discussed what is reserve capacity. The reserve capacity equals to the plant capacity minus maximum demand. Okay, the maximum demand, plant capacity minus the maximum. T stands for time, hour. My students, T stands for time. One student says Shubka. What T is stand for? T stands for time. Okay, time means hour. How much hour? So I'm just going for the reserve capacity one more time. So what is reserve capacity, or how to identify that? Okay, so you see that this is the maximum point. Okay, this is the maximum point of this load curve. So this maximum point, yes, this is the maximum point in the load curve. So it has the maximum demand. So if I want to establish a power station, I need to establish the power station minimum, the capacity should be, suppose this point is 6 megawatt, so minimum it should be 6 megawatt. Otherwise, if it is less than 6 megawatt, I cannot supply the power to the all people at this 6 p.m. because at 6 p.m. it requires 6 megawatt. So this is the maximum demand. Okay, so what should be then the capacity? The minimum capacity will be the 6 megawatt, but for future expansion we need something more. So suppose for that I make the plant capacity 8 megawatt. I build 8 megawatt. So the what is the reserve capacity? The reserve capacity is, sir, 8 megawatt. Now the plant capacity 8 megawatt minus the maximum demand. So the 8 minus 6, that this 2 megawatt is the reserve capacity for future expansion. I think you understand. Okay, plant use factor. Plant use factor, it is also a ratio. You can see that the plant use factor is the station output in kilowatt hour and the plant capacity and hour of use. So if we get those value, if we put that, we can get that how much the plant has been used. You see that, suppose an example is given. Suppose a plant having a installed capacity of 20 megawatt. The capacity is 20 megawatt and produces annual output. That means in the whole year 7.35 into 10 to the power 6 kilowatt hour annually. It produces annually and remains operation for 2190 hours. So how much the plant has been used of its maximum capacity? How much percent have been used? So if I just put this value, this is the station output for the whole year. This is the plant capacity 20 into 10 to the power 3. The megawatt we convert into the kilowatt, and the hour used we get that 0.167. If we make it the percentage, this is 16.7%. That means the plant has been used only 16.7% of its capacity. Okay, how much the plant has been used for its overall capacity? It's just a ratio. It's just a ratio, from which ratio we transfer to the percentage and we get the value that how much the plant has been used during this time. Okay, so that is plant use factor. This is the last topic probably, that to find out, to build the equation, that it's a very important term that we need to find out in the mathematics very often. One new word, that is annum. Annum means in a year. Units generated per annum. Per annum means annual year. Okay, 1 year, per 1 year. So basically, if we need to find out the units generated per 1 year, we need equation. So how we developed? We know the load factor equals to average load divided by maximum demand. We just cross multiply. So then the average load will be the maximum demand into the load factor. And we all know that, sir, average load throughout the year. Okay, average load, and if we multiply the average load with the hours of the whole year, in the whole year the total hour is 8760. So if we multiply with this, we will get the total units generated per year. So average load into hours in an hour. So we just replace this average load into maximum demand into load factor, and the hours in a year is 8760. So this is the just the representation of finding out units generated per annum or per year. So you will just use this equation, that units generated per year equals to the maximum demand, the load factor, and the year total hours. The total hours in a year is 8760. Okay, so that was the thing probably I think I have right now for first class. And the course is totally based on mathematics, so I think some students will enjoy, because if they enjoy mathematics, and some students will feel boring because there is too much mathematics. And these equations, that this every formula is very important for mathematics. We'll start this type of mathematics in the next class, but please try to understand first, then memorize. Try to memorize, because with the memorize of this equations or this formula will help you a very lot. So I will recommend all the students to try to understand first, and then memorize the equations. Now that was the end. I'm just